Greetings and welcome to the next in a series of webinar sessions hosted by Continuent. Today we'll be discussing comparing Amazon's RDS with Continuent Tungsten solutions. Point of housekeeping, the presentation for today is attached as a handout. We will be recording, and at the end of the session, sometime within the next 24 to 48 hours, we will be distributing the video as well as links to the PDF presentation. Questions may be asked within the panel, and we will attempt to get to as many as possible. However, if we do not get to your question, have no fear. We will attempt to get to it as part of the reply email at the end of the webinar. So again, let's get started. Today is again about Amazon RDS and how well Tungsten Clustering can provide a better, deeper, broader, more easily managed, really, solution when dealing with enterprise-level database services. So we need to start out by saying that Amazon in general and the RDS product that they offer are excellent, well worthy of respect, and we believe deeply in the Amazon platform. In fact, if one considers architecturally building for the business that you're working with, then you may actually choose RDS if you're a small business. But the focus of this particular presentation is about enterprise-level clustering, enterprise-level database, enterprise-level business needs. So we are definitely not focusing on the small shop with small traffic with one or two servers. That's not where we're going with this. So let's start thinking about the decision points when dealing with the choice between RDS and Continuent Tungsten. Failover, workload, traffic, and disk I/O. How well do we handle read scaling? Can you do maintenance? Do you have to take your systems down? Or can you do them where there's very little, if any, interruption to the application? And finally, what is the cost comparison? Is it much more expensive to do one or the other? Let's find out what value we get for each solution, what's included and what's not. So we are going to focus on the technical aspects of performance, high availability, where we might lose an instance, disaster recovery, where we might lose an entire region. We'll talk about different available topologies, like multi-site, multi-master allows us to do active-active across regions, not something that Amazon offers right now. Please note, of course, that this comparison takes an MySQL RDS deployment and compares it to Continuent Tungsten running on Amazon EC2 instances. So there's a lot of similarity in the underlying infrastructure. It's simply a matter of the offering and the management thereof. So let's proceed. We're going to dig in great detail into each of these different topics in the upcoming slides. But just to set the stage, let's briefly go over what the differences are between the RDS and Tungsten solutions. So one of the main things about RDS is that it's synchronous under the covers. They actually move disk level bits and bytes between availability zones. That is inside a region only. And so there needs to be, in a synchronous environment, an acknowledgement of a rate. In a very high traffic situation, if the target is unable to keep up, then the acknowledgements of those rates will be delayed, and therefore performance will suffer. Our replication, on the other hand, is much more loosely coupled and is asynchronous. So the server does not need to wait for replication in order to handle an operation. a write, an insert, an update, or a delete. Next, high availability. How do we handle failovers? RDS uses a DNS records, CNAMEs, in order to do a failover. So, what that means is two things. First off, there's going to be a disconnect. The application assuredly will lose connection with the database server. And secondarily, you may deal with propagation delays, especially if DNS caching is in the way. So this relies upon the fact that your application will see that DNS update in a timely fashion, will have to handle the reconnection, and it will then finally fail over. Time to fail over will be in the order of 2 to 3 minutes at best. It can certainly be longer if there's a lot of writes that are waiting. On the other hand, a continuing cluster will fail over in between 10 to 30 seconds normally. And depending on how you've configured the connector, which is our proxy, the application will see no downtime, will see no interruption of service, and will not need to reconnect when in either proxy or smart scale modes. So this is a definite advantage over the DNS method of failover. Disaster recovery, when we talk about loss of region, it doesn't happen often, but there is precedent. Amazon has lost regions, and therefore, if your application is global, is multi-region aware, and you have application servers that live in other than that region, then it would be great to be able to serve your customers in the event of a regional outage. And we offer two different types of disaster recovery. The one I'm talking about right now is called Composite Clustering, and allows us to fail from region to region with a single command. And that will support multiple regions, more than 2, if you so desire. Additionally, next line, if we go to multi-site, multi-master topologies, they're active all the time. No command to failover is required. And even if you lose a region, any and all other regions should stay up and connected. When we talk about read scaling and performance, RDS only provides for 5 read replicas per master. You can cascade them downwards, but it's really only 5 per. So there's no unified management of these replicas, and they use native asynchronous replication. You have no access to those replicas, unlike Continuent Tungsten nodes, where you have complete and full access to the slave nodes. Additionally, when you create high availability in RDS, the standby replica in RDS is unavailable for reads, unlike the Continuent Tungsten nodes, where all nodes are available for reads. And let's see, what else? Okay, RDS has some fairly substantial barriers to administration. You do not get super or shell access to the server, and you may only modify the environment, the MySQL variables, by using performance groups, which you can't do on the fly. You have to do with a restart. On the other hand, when you have full control of MySQL on an EC2 instance, you can have complete super access, root access to the box, and your administration, both OS and DBA, become much simpler and much fuller and broader because, of course, you have complete access. Finally, RDS does prevent you from using certain plugins, and we do not. Okay, so that's the summary. Now, we already talked about this. Performance. So in doing research about the difference between I/O performance, database performance running on RDS versus database performance running on EC2, tests were done, and what it boils down to in general is that if you compare MySQL 5.6 to MySQL 5.7 running on EC2, 5.6 is actually a touch better in these particular tests. And then if you travel downwards, we see that EC2 5.6 is approximately the same as RDS 5.6. However, 5.7 on EC2 is consistently better than RDS 5.7. And of course, as you migrate upwards or upgrade through the different versions of MySQL, eventually you're going to hit 5.7 and potentially beyond that. And so performance considerations are always worth looking into. All right, so here's some pretty pictures where we talk about the differences in how RDS handles high availability and failover. Now, we've already spoken about this, so we'll just summarize by saying the application will look up the endpoint host name, it will find an IP address, and it will start talking to the MySQL master. Upon failover, DNS records will be updated. The application will need to do a hostname resolution again, and when it finally does get that and gets a new IP address, it will then have to reconnect to the standby. Propagation delays and disconnects are at the heart of why this is not as healthy as we might like to offer in an enterprise level deployment. Tungsten, on the other hand, uses what's called a connector. It's an intelligent proxy. And when your applications connect to the connector is responsible for rerouting the traffic, not the application. So if the master should fail, the application will automatically be sent over to the newly promoted slave. And that's a significant savings in terms of customer perception time, everything. Very briefly, a continuent Tungsten cluster looks like this, where we have replicator layer using the Tungsten replicator to move the data. Managers check the health of each node and communicate that health to the connectors, which are the intelligent proxies. Applications connect through the connectors and are able to get reads and writes from the master, obtain reads from the slaves when optionally configured for read-write splitting, and so forth. We can cover more details about how clusters work on another session. So the details here about high availability summarize: physical synchronous replication. Standby replicas are not available for reads. They are locked down. You can't get to them. Failover is longer. Failover is fraught with potential hiccups. And there's no graceful proxy between the database server and the application, so it just dies. As discussed, we're asynchronous. All of our nodes are available for scaling. All of our nodes are available for access. Failover is very fast. It's handled by the connector, so there's no propagation delays, and everything is as graceful as we can make it. So let's talk about disaster recovery. Here we have two different clusters, one in each region, and they are tied with what we call composite clustering. It is in this scenario that you would have to issue a single failover command to flip between regions. We do that deliberately because you don't want to be flapping between regions. We want that to be a deliberate decision for you to change your master role. RDS does not have any sort of cross-region failover. You may place a replica in a different region, and you may promote that asynchronous replica with no guarantee whatsoever whether or not you're going to have all the appropriate data. You can't really access it properly, so it's hard to dig into it to find out if it's right, and certainly it's not going to be quick. We, on the other hand, fully support multi-region failover. You can do it, as I stated, one of two ways, with either composite clustering and multi-site active-active. In this slide, we talk about composite clustering because the connectors are actually aware of remote sites. So the connector can actually reroute traffic from one region to another. That's a very powerful thing. And that allows application servers and remote data centers to survive the loss of an entire cluster and have it go over to the other side. We also have the ability to inspect our THL, transaction history logs, which is where we store all of the events. That allows us to see where everyone has gotten to, and it makes recovery significantly easier. Here We have active-active clustering. So we would have two or more sites joined by multi-way cross-site replication. Write to site A goes to site B. Write to site B goes to site A. That way, they're live all the time. No command is required. In RDS, no such thing. They don't have active-active multi-region solutions. We, on the other hand, handle this very easily. Again, we provide high availability locally with the cluster, and then create a replication stream between all of the different regional clusters. The best part is that a Tungsten topology allows for failures. So if I am in site B, receiving traffic from site A, and the master should fail over in site A, we can follow the data and continue to pull from site A to site B. So we are failover aware. We can also use multi-site, multi-master in a behaviorally passive way. Even though one region might be writable, you may choose not to write there. For example, if you have a global load balancer, you may choose to send all traffic just to one site, and then at some point you can flip that traffic to go to the other site. All data will be there, and if you flip, then all data written to site B will automatically get written back to site A. Many of our customers will routinely do this test failover potentially once a month or even more often to validate that entire data centers and regions are working well. This is an extremely powerful tool because you can test your disaster recovery scenarios with no application downtime. We think this is a very useful tool for maintaining enterprise-level data availability. So read scaling, again, we've mentioned the fact that standby replicators in RDS are not available for reads. So you must create asynchronous MySQL native read replicas. You can launch them and you can destroy them, but it's very, very hard to administer them. And should you want more than just the 5 attached to the master, you can cascade one level down for a maximum of 30. There is no read-write splitting inherent in RDS, therefore you would have to deploy some third-party solution, some sort of either application-based or proxy-based load balancer to pick up on all of these read replicas. So there's no inherent knowledge of the replicas by the application. You have to design and build that yourself. On Continuent Tungsten side, every node in every cluster is available for read and can be a failover candidate. We can also isolate specific slaves so as to not be failover candidates, for example, a backup or reporting node. However, all normally would be available for both reads and failover. You can increase the number of nodes in a cluster to increase the number of reads. We always recommend an odd number of nodes. Aside from that, that should allow you to keep scaling upwards. We also recommend using the composite model to create separate clusters for read capability. So instead of having a single point of failure like a read replica, you can actually use an entire cluster as a source for reporting and any other sorts of activities that you may not wish to have impacting your front-end OLTP data. So with those sorts of designs and topologies, there is no real limit to the number of read replicas and clusters that we can provide, especially in the one-way replication model that you see at the bottom. And finally, we are also able to replicate out to big data targets from our clusters with the same type of cluster slave reliability, where it will be sensitive to a failover and make sure that data continues to flow downwards to the target. This makes the entire thing extremely flexible and powerful in terms of, again, enterprise delivery of data. We never want this stuff to go down. We always want the data to flow, and we want it to happen as quickly and cleanly as possible. Another thing that RDS tends to promote and market is that it's easy, it's simple, one-click launch of a database and you can run your entire business. Well, again, for a single small website, that might be just the ticket. However, there is no way that you can single-click launch an entire global database infrastructure in RDS. It just can't be done. You have to architect it, think about it, and use a wide variety of DBA efforts and talents to achieve that goal. So additionally, there's no support built into the RDS pricing model. You have to get that separately. And in order to get any kind of actual architectural help or actual design help or true DBA as opposed to just basic support, now you need staff or consulting services. So let's look at the model that Continuent Tungsten offers. Well, we know for a fact that you need DBAs. If you're going to run an enterprise environment, you have to have staff at least part-time dedicated to this thing, or it's just going to get unhealthy over time. So we know that you're going to need either in-house staff or you're going to need to hire some outside talent to make all of that happen. When we apply our product into any type of environment, we provide you with consulting services up front. We help you architect, design, integrate, and implement your solutions. We work with you so that we get you into production. We don't just drop an account in your lap and say, here, go to it. And we will help deliver the software into production and make sure it is stable, backed up, and monitored so that you are able to run this properly. When you purchase a Continuent license, 24/7 enterprise level support is included. We have follow the sun staff. We are available in most every time zone, and our average response time is 6 minutes to an urgent case. So you will get help. You will get help fast. You will get help well, and you will get an experienced engineer that will not require you to escalate through 3 or 4 different layers to actually get the answer you want. You get us right up front. What happens when you try and administer RDS? So let's think about some of the basic opportunities for upgrade and changes that we might have to take in order to keep our environment up to date. So for example, if you want to upgrade from 5.6 to 5.7, well, that's going to force downtime. If you're multi-AZ, you have to fail over to your standby, so that guarantees a minimum of 2 minutes, probably more. And you can't plan a no downtime activity. There's no such thing as rolling maintenance. It's down. With a cluster, Tungsten is able to allow you to shun one of the slave nodes, perform your upgrade, bring it back into the cluster, repeat on the other slave or slaves, and finally, when you're ready to do the master, you simply fail it over. And when we fail over again, it's maybe 10 seconds, and the applications perceive that as a pause, as a network hang when you're in proxy or smart scale modes. So they'll just hang for a second and then just keep going. No reconnect necessary. Right? So we call that rolling zero downtime maintenance. Next, when you deal with RDS, sometimes they'll choose to do an OS upgrade in the middle of your MySQL version upgrade. You have no control over when that happens. That could potentially increase the length of your upgrade time. For us, same thing applies. You want to upgrade the OS? No problem. Shun the slave, upgrade the OS, bring it back in, and so forth. Everything is done gracefully and smoothly, and you have complete control. When you change the parameter groups, if you need to upgrade change a variable or tune the server, guess what? You have to actually stop and restart MySQL, and by RDS standards, that's a server restart. Again, more downtime. when you have MySQL running on EC2, you have complete super access. You can, on the fly, change a global variable, or decide when you want to restart MySQL. But again, you can do that in a rolling fashion by shunning a slave, doing all of your tuning and restarts, bringing that back into the cluster, lather, rinse, repeat. So again, you can do everything gracefully. When you're on RDS, forget about trying to log into the box. No can do. So all of the typical tools that you're used to having as a DBA to go log in and do what you want to do, not there. No can do. Got to do it their way, and you got to pay for it. With Tungsten, we give you various plugins for Nagios and Zabbix monitoring. Set it up any way you want. You want New Relic? You got it. So in general, when you do things with Tungsten on EC2, it's business as usual. Things are not locked down. When you do things on RDS, things are really locked down tight, and it makes it extremely difficult to get enterprise level work done. So how well do we do failover? Well, Tungsten does fast, recoverable failover. RDS, not nearly as much. We can easily provide you enterprise level workload support by allowing you complete access to the instance, where you can use industry best practices to create high I/O, provisioned IOPS EBS volumes, and stripe them. And that way you can get significantly high I/O. You can also do that on multiple volumes and partitions. Therefore, you can spread your I/O across stripes and across volumes and get extraordinarily high throughput. That's very difficult to achieve on RDS. Their I/O is good, but they can't do that. And of course, Tungsten allows us to read from all nodes, so your dollar goes further, and we have no practical limit on the number of read scaling. Additionally, we can create clustered read scaling opportunities where with RDS you only get single replicas. So EC2 rather, it costs 30% less on average than RDS. When you add in our software license plus the support that we offer for free, basically you're getting a significantly superior solution for roughly the same cost. It makes perfect sense, both from a cost, feature, and performance perspective, to use Tungsten clustering on EC2 instead of RDS. We provide high performance, high availability, complete access to MySQL, and we do not have the latency that synchronous I/O creates. If you have any questions, would like to get in touch with us, please don't hesitate to reach out. We are very happy to set up one-on-one discovery calls with you. Proof of concept is our bread and butter. Let us show you what we can do. Thank you very much for attending our webinar. I hope you enjoyed it, and we look forward to seeing you at the next one in 2 weeks. Thank you, and goodbye.